2.6 billion people love mobile games, including me. And in this video, I'm gonna make one. And while making it, I learned a lot of new and exciting things that you may have not known about game dev. And I really think that you can take something away from this video. And if not, have a good time. And the first step to making a mobile game, or any game rather, is planning. And I want to remake one of my Game Jam games for this project and then just add a bunch of new stuff on top of it. So I got to brainstorming and came up with a rather large list of all new ideas that I wanted to add to the game. And to sum it up, the key points were revamped weapon system, power-ups, missions, co-op mode, and fully customizable games. And once the brainstorming process was all over, I made a new Unity project. Hey Will, why don't you just add on to the Game Jam game? Starting over seems a little unnecessary. Excellent point, viewer, but I have a reason. If you haven't seen the Game Jam video, just know that I went about programming all this stuff in the messiest and most inefficient way possible. So by remaking the game, it will make adding on the new things a whole lot easier. Oh my goodness, you're a genius. I know, right? I'm just so smart sometimes. And humble too. Of course, I don't think I know anybody more humble than me. And hands. So, the first thing we need is the grid, and that won't be too bad to make. I'll have a multi-dimensional array of cell objects, each with their own coordinate. The cell will have a specific color and alternate that color to make a checkerboard pattern. I'll also have a flexible grid size so that the user can enter their own dimensions into a custom game. Next up is the player, and he needs a random cell to start on. So after picking a random X chord and a random Y chord, we can take the player's position and put it on the cell's coordinate. And I know, watching a stationary green dot is pretty exhilarating, but I'm about to blow your mind with what's coming up next. We're gonna make him move. When it's the player's turn, he's gonna listen for input on the keyboard to get his direction, and then roll a die to determine how many spaces he's gonna move in his direction. All things considered, it wasn't that hard to program, but it did take a little bit longer than I thought because, well, I'll tell you in a little bit. I also made the camera smoothly follow behind the player, but he isn't even moving smoothly himself, so let's change that. One lerp vector and an animation curve set to ease in out later, we've got nice smooth player movement. And now that we have our player, we need some enemies. But before that, I'm gonna have an intense philosophical debate with myself. If you're playing co-op mode with one of your friends, is that friend technically your enemy? And are you technically the enemy to him? So to avoid all that, everyone's a player. You're a player, he's a player, the AI bots are players, and I'm a player. Ladies? What I mean by that is we're gonna have an abstract class called player, and two classes that will inherit from player. AI player and controllable player. Because all the players pretty much act the same, regardless of whether they're controlled by the AI or the user, we can put a lot of their shared behavior inside the player class, and then put the differing behavior inside the inheriting classes. This will save us a lot of time and a lot of duplicated code, so I think it's worth it. And I have a confession to make. I already did all this. Back when I was making the player movement, I anticipated this would happen, so I just went ahead and did it. So that means implementing AI player movement was super duper easy. So I whipped up a quick game manager script, which has a fancy icon for some reason, and it lets me pick the number of players, the number of those players who are controllable, and a random order for the turns. I also made a mode where the camera follows every single player, which I like a little bit better, so I'm going to stick with that for the rest of the video. But with all that said, here it is. Right now, like in the Game Jam video, the AI players aren't very smart, and they just pick random directions to move in. So to fix this, we need to ask our AI player to look at every other player and then determine which one is the closest to it, and then try to follow that player. And once that was done, I let the player attack in a one-tile radius. They don't do any damage just yet, but they're pretending they are. And once they finish their little attack, they'll have the option of running away, so it will be harder for the victim to chase them and get revenge. Now that we have the turn pretty much done, it's time to move on to the art. I started by making two sprites for the cells, one with a border and one without a border. And if you recall from earlier, we get to pick our own colors for the grid. But here, I'm making it only white, so that means we can't pick our cell colors anymore. Right? Wrong. First, we gotta talk a little bit about colors. So if you don't know, a computer screen is basically made up of millions of tiny lights called pixels. And these pixels have a color. To get this color, the computer adjusts the levels of red, green, and blue displayed by the pixel. If you've ever used anything like Photoshop, you usually adjust these RGB values from 0 to 255. But computers think a tiny bit differently and go instead from 0 to 1, where 0 means no color and 1 means full color. This means that the RGB code for black would be 000 and 111 for white. Making sense? I hope so, because we're about to be doing some math with these colors. So in the cell sprite, all the white pixels have an RGB value of 111, because that's just what white is. And the border has a color of 0.2.2.2, because it's technically not a full black. So what we can do now is take every single pixel and multiply it by a new color. For example, let's just use this random bluish color of RGB 0, 0.48, and 0.75. Because white is represented with 1, and 1 times any number is the number you multiplied 1 by, we can multiply white by any color and just get the color that we multiplied. This is perfect, and then the border colors will remain dark because the value of them is very, very close to 0. And a number close to 0 multiplied by another number makes that number smaller. Pretty neat if you ask me. Before I could even think about making something else though, the inevitable happened. The first day of school. And I didn't return to the game for about a couple days. And once I was back, I finished up everything that I needed for the sprite sheet. I made some weapons, some power-ups, some chests, some dice, and some players. Because there are a lot of different poses that the player will have due to the amount of weapons that he can carry, it would be really silly to duplicate each one of these poses to just change the color. So I'm going to take a little trick we used with the cell example here. I'm going to make the player's clothes a full white, and then multiply it by the color that I want the player to be. And spoiler alert, this doesn't work. Now it's time for a pop quiz. Why does this not work? A, the background of the image turns into a different color. B, the player's hair, skin, and weapon also turns into a different color. C, white is actually RGB 000, so nothing happens at all. And D, it works. Stop trying to prank me. Alright, now make sure you put your answers down in the comments, because the answer is, drumroll please, B. So this means we have to come up with a new plan. And I'm thinking we use a shader to replace the white in the player with our new color. Using shader graph, we can take the sprite sheet and put its color into the in input of the replace color node, and use white in the from input to specify that we want to replace the white in the image. Then we input a new color into the to input to specify that we want this color to be replacing the white. And then we drive the output into the base color. And it works! Kinda. Due to the white in the player's eyes, part of their eye is being replaced with the color of their clothes. So what we can do is split the image in half and replace the color in the bottom half, and then put the bottom half with the replaced color right underneath the top half with the normal color. And that last part sounded pretty easy, but explaining all the shader stuff would take a while. If you're interested, I'll talk about it down in the description, so check that out. And that's one of the main reasons I love game dev so much. You can take a really tricky problem and approach it at so many different ways and still get the desired result. But anyways, a little while later, I made all the players spawning in with their new randomly assigned colors. And I also added in the dye sprites. And I'm really liking the way this is turning out. Oh, and going back to the customizability thing, we can add and remove colors that we want the player to be super easily. Next things next is getting all the weapons in. And to make these weapons, I use something called scriptable objects, which is kind of like a fancy data template where I can just make a new scriptable object, fill out a little bit of information, and then boom, I got a weapon in the game. That's the idea at least. This whole system has yet to be completed, because I was at a stage where I needed the player picking up weapons off the ground. So naturally, I shifted my focus to chests. Much like everything else in the game, the number of chests is going to be completely customizable and spawn randomly around the grid. But there's no point of having chests if they're not going to do anything. So let's fix that. Now the chest can be opened and will always drop a temporary heart pickup that does literally nothing right now. And as you can see, the AI players can also open the chest too. But that's only if they're right next to the chest and there's literally nothing else to do. They just ignore them most of the time. But that's an issue for another time, because I want to get the chest spawning all of their items in first. And I know I sound like a broken record here, but I really want this game to be fully customizable for the user. So I want there to be a way to control the distribution of the power-ups.
Did somebody say I want there to be a way to control the distribution of power-ups?
Oh my goodness, it's the distribution class.
Fear not, civilian, for I am here to save you.
Thank you so much, distribution class, for being able to take in a list of items and a list of drop chances, and then randomly picking one of them and returning it back to me. And the fact that you're generic and can work with literally anything makes you so much cooler. Wait, how have I never heard about this before? Well, dearest viewer, it's because I made him. And you can use him too, for the low price of just $0, just by checking out the link in the description. In all seriousness, writing that little script made making customizable distributions super easy. Technically right now, they're all just uniform distributions and they can't actually be customized, but changing that would be super easy. And I'll get into that when I start making the UI. And just like that, now all the chests are producing their appropriate items according to their distribution. It's been roughly 1.5 weeks so far of working on this game, and I actually made more progress in the 48 hours it took for the game jam. And this is partly because I took a small break for school, but more importantly, I've been learning new skills as I go. In a game jam, there's no time for that. So now that I've got the time, I'm using it. So even though this is taking longer than I expected, I am really happy with the way things are going. But that's not the end, because we still have a lot of fun and exciting things yet to come, like actually turning this into a mobile game. So make sure you click right here to see how it all ends. Thanks for watching. See you there.